is given by Professor Armin Gruen. He has worked on this topic at the ETH Zurich for many, many years. And so, Armin, please go ahead.
Okay, good morning, everybody. I'm happy to be here because last year I missed the conference. And like always, it's a very interesting and important event. So my first talk today is about combined modeling from UAV images and laser scans. And my example is a project NUS, that stands for National University of Singapore, the campus of this university. Now, the Prime Minister of Singapore, in his National Day rally 2012, singled out UAV as a key future technology for the next 20 years. And I quote, "UAVs will have many uses in the future, civilian and military. But there are also political uses." You may have read in the newspaper last weekend, there was an event in Serbia where they have used a micro drone to attach a flag. And so that's a political application beside military and civilian. Now, our community is using UAVs for a number of years. My own group started in the year 2004, but we use it in a very basic manner. If you look at the robotics groups, then you will see they are much more advanced in terms of using UAVs as robots. Our UAVs that the mapping community is using are dumb. They cannot react, for instance, to obstacles. But as you can see here, UAVs can be programmed in a way that they can react to their environment. But again, our community is still far away from this kind of use. UAVs, the messages I would like to convey today is 5 or 6-fold. The technology is interesting, it's exciting. Students like it very much, for instance, they're very motivated. There are many, many systems on the market. The issue of low cost is questionable. The good ones are still fairly expensive. Then definitely with this technology we can get a lot of new applications. But on the negative side, the technology is not mature. We have many, many software and hardware problems. Good application software is missing, and there are safety issues. Let's look at the safety issues first. This is the Zhukov Tower in Polybino. Our Russian friends know where it is. It's south of Moscow, and we worked there. And we finished almost the project with a UAV, with an octocopter. Then the navigation system went crazy. And the platform went full speed into a house, into a building, and was totally damaged. In another case, a couple of months ago in Malaysia, a child was even killed by a mini helicopter. So the technology is far from being mature. It can be potentially dangerous. And now you may understand why government agencies are in many cases very reluctant to give permissions to fly. UAV systems have been used for many, many years now, but we use it in a photogrammetric mode. And for this purpose, they have to fulfill a number of functions which I have listed here. I'm not going through it, but if you cross-compare with the functions that are offered by the manufacturers, you will find out many of these things are not given, are not available. So there's still a lot of room for improvement. Typically, such a platform is equipped with a navigation system, GPS INS, with a stabilization platform. And mind you, don't fly without stabilization platform, okay? Because the platform is very sensitive towards wind. You will shoot in all directions, but not towards your object. So in my opinion, stabilization platform is absolutely mandatory. Then you may have gas engine or battery-driven systems. There are also big differences between both systems. In Singapore, which I'm reporting about, we are using an octocopter, Falcon 8. We are not using it because it's so good. We are using it because it is so light, and the lighter system, the more likely you get a permission from government. And Singapore is very notorious about aerial images. I've never seen aerial images in Singapore. They're classified. So to get a permission, you have to fly at least a small system, lightweight system. Now, over the past years, we've done many projects worldwide, many applications, as you can see, even plant science, agriculture. I'm reporting here about two, the red one. One is a Singapore project, and the other ones are the Zhukov towers in Russia, which is related to construction engineering. The applications, Gottfried was talking about applications of city models. My experiences being now with the Department of Architecture, city planner like to use the city models. Designers don't do. Designers are still in the analog domain. There's a long way, according to my experience, before designers, city designers, I mean building designers, will use 3D city models. So it's okay for planners, but not for designers. Hydrology is an application in our case, autonomous car navigation, pedestrian simulation, and so forth. So there are plenty of applications. This is the area under discussion, the campus. There are particular problem if you use a UAV in a city. It's totally different from using it in a free space out in the countryside. In a city, you have various flight restrictions. Like we were not allowed to fly on the weekend. Throughout the week. We could only fly on the weekend because there were less students on campus. We were not allowed to cross major roads with a UAV. We were not allowed to fly higher than 150 meters. Then you have radio interference in the urban area, much more than in the countryside. You have limited takeoff and landing spaces. So a fixed wing is not a good idea in the city. You don't have enough space. You have very short flying time, and then specifically in our project, we had very steep terrain. You wouldn't expect it in Singapore, but in fact there is steep terrain. Very high buildings, 150-meter flying height, 100-meter height buildings, tropical vegetation. These are all big problems. So I show you quickly how we start. For instance, how we take off from top of a building. Our pilot is shaking to loosen up the INS system. Oh gosh. So we always start in a manual mode because navigation system never is good enough for automated takeoff. So it wouldn't be able to go through these pillars without crashing, possibly. So we start in manual mode. As soon as the system is in free space, the autopilot will take over. And the same with landing, okay? We always land in manual mode. So now we are in manual mode. The system goes out into the free space, and the autopilot takes over, and the mission is flown fully automatically. So we generated all in all about 900 images, and for this purpose we needed 43 sub-blocks. And this because the flying time is so short. If you have 15 minutes flying time, it takes 5 minutes to go up, it takes 5 minutes to come down, then you have 5 minutes left. So you could do 4x4 or 5x5 images. So we needed 43 starts and landing, and this is highly inefficient and creates problem with the data processing software, as I will explain you in a minute. Also, you have to calibrate your camera, of course, because the manufacturers don't know how to do camera calibration. And then if you do everything all right, you get a nice overlap within your small blocks, like 4x4 or 5x5 images. And the resolution in this case was about 5 centimeters. So you see a tennis ball. I don't know if you can recognize it, but you can see a flying tennis ball with such a resolution. So we have two main steps in data processing. One is georeferencing, and one is model generation. And when we discuss model generation, we not only have buildings, we have all kinds of objects, including trees. We have measured and modeled alone 3,000 trees on campus. Okay, first of all, georeferencing, which normally is considered a standard problem in photogrammetry. It did not work. We have tested 5, 6, or 7 commercial, non-commercial software packages. Only one worked. Out of 6 or 7, I forgot. LPS, for instance, didn't work because we have forest area, and tie point generator didn't work. So we developed our own software for this purpose. And then we fed the tie points into the LPS bundle adjustment software, and out came results which are not acceptable. 1.6 meter error in checkpoints given 5 centimeter pixel size is much too bad. So we checked a number of commercial packages. I'm not going into detail. We have 3 here, or 2.5 here. We have 2 more here, and only one worked. This is Apero. Apero was the only package that gave us reasonable results. And if you compare now the RMSE, you just look at the last line here, you are around 1 pixel accuracy, which is acceptable for us. So in fact, we not only use aerial images from UAV, we use oblique images partly, we use raw point clouds from MMS, terrestrial images, and we use existing data, maps. So for instance, for DTM, because of tropical vegetation, we couldn't look through. Even a laser scanner couldn't give us all information, so we also integrated contour data from terrestrial maps. So we did some tests with fully automated generation of surface models, but even the best software, Shure, was not good enough to deliver the results. So we use CyberCity Modeler to measure the buildings in a semi-automated mode. You measure also terrain as far as you can do it. And then you texture map. And if you look into, if you zoom in, you see the level of detail which you can achieve with 5 centimeters. So here's an image of the model resolution. I would have a flyover, but it takes too much time. We took terrestrial image for facade modeling. And then we had a mobile mapping system in town, which was used for flood modeling in Singapore. So we asked the guy, the system was from Portugal, we asked the guy to also run our campus, which he did. So first he did Little India, where we also have a project, that's a different one. Then he ran 16 kilometers through our campus, and we had big problem with the loss of GPS signal because of high buildings and of trees and vegetation. So many systematic error. What do? we generated control points, not by GPS, this is too time consuming, but from UAV images, okay? We compared UAV image with point cloud and extracted from the UAV image additional control points in order to improve the situation, the loss of information. And finally, we got reasonable result. I cannot go into detail, not enough time. So what we have now, two kind of data. We have UAV images and we have terrestrial laser scans, and we have to bring everything together. On the left side, you see what we get from UAV images, the roof in 3D. This is a typical point cloud from laser scan, highly incomplete, and this is the final result, the complete model, which includes not only a roof but also 3D facade. This is our office, the same story. This is a visualization of our office area, create building. And this is now the overall model, not including trees. Why not? Because it takes too much time to visualize it. This is about 3-minute video clip. I don't show you everything, takes too long. But it took us 42 hours to produce it on a 4-CPU PC. So we are far away from interactive visualization here. And if I would put in the trees, the 3,000 trees, it would be much worse, okay? So this is our main problem now. We have good technology to produce a model, but we have no good software or no good hardware, or it's too expensive. Of course, Google could do it, but we can't do it to show this data interactively. Some brief words about tree modeling. We use the point cloud from laser scanner, and we go through a semi-automated 5-step procedure where we use commercial packages like Geomagic or 3D Max to model the tree. There's another case, tree A, a palm tree. So we have 3,000 such trees, but we can't show them. There's too much data, okay? We also measure light poles, and we have 5 models of light poles. So we measure only a very few points, 1, 2, 3 points on the light pole, and we fit automatically a model, okay? And we measured 900 light poles. So these are examples where the different data sets are being combined. And finally, the data ends up on a GIS platform and is used by various users. Also, our university administration has requested it now for planning. I have a list of many projects which are currently under discussion in Singapore, projects which have almost nothing to do with conventional mapping. These are all new, or most of them are new applications, okay? Including pest control, dengue fever, mosquito control, and so forth. So I showed you how to use UAV and laser scan data, very high resolution, but we are also working on lower resolution project. This is an ongoing project, Morea Idea, Island Avatar. There are 2 islands, Morea and Tetiaroa. Tetiaroa became famous, both are in the South Pacific, I should say. Tetiaroa became famous because it was owned by the famous movie star Marlon Brando. The older of you probably know him, Marlon Brando, who died in the meantime, and it went into a foundation. And they have built a hotel. You talk about 5 stars here, they have 6-star hotel, $5,000 per night. But they want the model for whatever reason. But we don't do it for the hotel, we do it for scientific purposes. So here we use Pléiades images, Pléiades satellite images right now. It's an ongoing project. We have already a 3D model of both islands. We have a bit problem with texture mapping because they're heavy shadow area. You see in Morea very steep flanks with dark shadow and other problems. Some radiometric problems in the Pleiad images, which bother us a bit. But we also, and this is maybe quite new, we also have reef data. Reef data is already available from laser scan, green laser scan, and bathymetric data and sonar data. So we will connect the reef with the land and have a full system. We also will use aerial images. The French have produced old aerial images, so we do change detection. And we're also preparing, of course, a GIS platform and invest in visualization animation. So an ongoing project at a much different scale, but quite exciting because of the area. So my conclusions are model helicopter, as we probably, I say model helicopter, but I mean all UAVs are flexible, very flexible devices, potentially at least for recording. Flexibility in terms of cameras, you can use different cameras, different lenses. In terms of orientation, you can take vertical images, oblique images, you could horizontal images with some of them. You can even take images in the upper direction towards the sky, if you fly indoors, for instance, or you can turn it around, fly upside down. So a lot of flexibility you have. Also in navigation, you can really fly close to an object, and you have online or real-time capability. It is cost efficient, partly at least, and there are many diverse applications if the area is not too large. I'm always asked by people, why don't we do the big city with UAV? Yeah, if UAV is a big platform, then you can do it. But the small platform, as I've shown you before, an area of 2 square kilometers needs 43 starts and landing. This is not efficient anymore. With this technique, you cannot do a full city, okay? So the area shouldn't be too large. This is the positive aspects, but there's also some negative issues. As I said, technology, system hardware and software is not mature. I will show you in my next presentation the cases where the systems failed. In most of our projects, something failed, okay? It not always fell down from the sky, but something always failed. So very immature in my experience. Also, operation processing of hybrid, so I mean mixed data, UAV images and laser scan point cloud is not available yet. What I've shown you was a separate processing. You have 2 pipelines, one for the images, one for the laser scans. But the integrated processing is not yet available, at least not in operational form. Yeah, I'm finished. So there's much room for improvement in data processing. This is for the young people who look for a PhD thesis or a master thesis. There's plenty of room. Also, it's still photogrammetry. There's really nothing fundamentally new. If you know photogrammetry, you should be able to handle it. Only the commercial software, and I'm not talking about PhotoMod here, but other commercial software cannot handle those special cases. And then, of course, there's the issue of flight permission and safety concern, as I've shown you before. Thank you very much for your patience.
Thank you, Armin. I think with your suggestion right now, if you carry on like that, maybe the next Rakurs conference could be in Tetiaroa. So.
Yeah, why not? It's, there are conferences, actually, scientific conferences in Tetiaroa, no problem. You just have to pay a bit more money than here.
Okay. A quick question, please. This is not the case, we have the other choice. Thank you very much. And the next